Bismillahirrahmanirrahim. Chapter 10 Circles, and this is the third lesson, Chords. Our main objective is to prove and apply relationship between chords, arcs and central angles. So if you do not know what is the definition of all these terms, watch the video of lesson 10.1 to understand the definitions of these. Then it says find the lengths of the chords given distance from the center of the circle and use this information to solve problems. So we have some theorems in which some rules we will discuss, and using those laws or rules you will solve some of the problems. So here quickly let's see what is the definition of a chord of a circle. So any line that you draw to join two points on the boundary of the circle. So look at this. For example, if I have this point B and I have this point P, if I join them with the help of a straight line, so this line is called the chord of the circle. A line segment that connects or joins two points on a circle's circumference is known as the chord of a circle. What about AB? Now AB is a special chord, you can say, that passes through the center of the circle. So still I'm doing the same thing. I'm joining two points that are on the circumference of the circle with a straight line, but this is a line that passes through the center of the circle, so it has a special name. What is it called? It is called the diameter of the circle. Clear? Now let's see what is the first theorem for this lesson. It's theorem number 10.3. The theorem says if two chords in a circle or in congruent circles are congruent, then their central angles are congruent. Now let's discuss only a single circle. For example, if you have a circle and you have two chords in the circle of the same size. So look at this. Here we have two chords MN and PQ. So this is the first one. Let me highlight it with a different color to show you. Here MN is one of the chord and we have another one. Here is the other one. PQ is the other chord. Okay, now what is given, or what do we already know? That the measurement of these chords is equal. For example, let's say if this one is 5 centimeter long and this chord is also 5 centimeters long, because we know that they are equal. So what will happen now? Now you can see that we have a central angle. If we connect these points with the center, we get a central angle over here, and similarly if I join the point MN with the center, I got a central angle over here. So if the chords are equal, then these two central angles will also be equal, or you can say the corresponding central angles will be equal. Clear? This is the first part, or you can say theorem 10.3. Now what is the converse of this? Obviously it will be opposite, that if you know that the two central angles are equal, like this angle is equal to this one, so angle MTN is congruent to angle PTQ, then what will happen? The chord MN and the chord PQ, they will be congruent to each other. Now here is an example. They are saying, now this theorem was explained with the help of one circle. Now very best example here, that let's say if you have two circles of the same size. When I say same size, that means the radius of each circle will be the same. Now look at this. You can see here, this is the radius of the circle. So how much is the radius of this circle AB? It's 3 centimeters. And look at the radius of the other circle. It's DE, and this one is also 3 centimeter. So this is the reason both the circles are congruent. And if you look at the central angle, what is the central angle given in this circle? It's 123. And what is the central angle given in the other circle? It's also 123. They want me to find how long is EF, like what is the measurement of this line segment. So using this theorem, the converse, I will say because angle BAC is congruent to angle EDF, and both of them, as you can see in the diagram, they are equal to 123 degrees. So these central angles are congruent. That's why the line segments or the chords that are made because of these, you can say, central angles, or by joining point B with the C and joining point E with the F, So BC will be equal to or congruent to EF, and what will be the measure of each one of them? It will be 5.27 units. Units means if it will be, they will be measuring in centimeters, it will be in centimeters. If they will be measuring in meters, it will be meters or inches. Clear? Here is theorem number 10.4, and the converse of the theorem. Theorem says if two arcs in a circle or in congruent circles are congruent, then their chords are congruent. Okay, what does it mean? As you can see here in the diagram, here we have an arc, it's MN, right, where my pen is moving, and then we have another arc PQ, and these two arcs are congruent. We know that these two arcs are congruent. So you can see here with with this arc MN, I'm getting a point M here, N here, and here I have a point N, M and N. So if I join these 2 points, I'm getting a chord. What is the name of the chord? It is MN. Similarly, for the other arc, I have this point and I have this point on the circumference. If I join P with the Q, I get another chord. What is the relation between these two chords? These two chords will also be congruent. What is the reason? Because their corresponding arcs are congruent. Similarly, if you look at the converse, it says if the two chords are congruent, I know that this line and this line, these two straight lines are equal. So what will happen? The two arcs will also be congruent, right? So let's see, what do we have to solve next? So next we have another theorem. Theorem number 10.5. It says if chords are equidistant from the center of a circle and the center of or the centers of congruent circles, then they are congruent. Very, very important theorem. It says, like for example, if you know that there are two chords, if the chords are equidistant from the center. So for example, if this is the center of the circle, and let's say I have a chord over here, and let's say I have a chord over here. Now I know that the distance of this chord from the center is 5 centimeter, and the distance of this chord is also 5 centimeters. So if they are equidistant from the center, then what will happen? What can you say? Then they are congruent. Then this, for example, this is AB and this is CD, then AB will be congruent to CD, right? So here if you look at the diagram that they have drawn for you, it says we know that there are this line segment. Let me show you here, from S to E and from S to F. These two line segments are showing the distance from the center to the chord. These two, and you can see here this symbol, that means these two distances are equal, or you can say these two line segments are equal. So we know that line segment SE is congruent to line segment SF. So what will happen? It is taking us to the chord AB. So the length of the chord AB, or the line segment or the chord AB, will be equal to the chord CD. Distance from the center to the first chord, and the distance from this distance. And similarly, if we take this distance to the other chord, so these two distances will also be congruent. Clear? So here is the next theorem, 10.6. It says if a diameter is perpendicular to a chord, then it bisects the chord. Okay, as you can see here, they have shown us with the dotted line the diameter of the circle, right? And we have in this blue color, a chord that is AB. We know that this diameter is perpendicular to this AB. That means that we have a right angle over here, right? So what will happen now? This distance A to E and E to B or B to E, they will be congruent to each other. And if we look at the converse, it says if a diameter bisects a chord, like here it is showing that it is bisecting this chord AB. Bisecting means it is cutting it into half. Then it is perpendicular to the chord. Then AB, this AB is the chord and CD is the diameter. So the chord and the diameter, they will become perpendicular to each other. Clear? Okay, last theorem, it says theorem 10.7. The perpendicular bisector of a chord contains the center of the circle. So if you draw the perpendicular bisector of a chord, okay, let's say I have a chord over here and the name of the chord is AB. If I make a perpendicular bisector, now what is the meaning of a perpendicular bisector? Perpendicular bisector has two words. Like I have to draw a line in the bisector point, like in the half, and that line must be a perpendicular. So this is the midpoint. If I draw a line over here, so what can you say about this dotted line? This dotted line will always be it will be the diameter of the circle, right? The perpendicular bisector of a chord contains the center of the circle, because this is the diameter of the circle, so it will always pass through the center of the circle. Clear? As you can see here, the blue line is showing the showing one of the chord, and we have this is the midpoint. And if we draw the perpendicular bisector from this point, then it will be not only perpendicular, but it will also cut this line and this chord AB into two equal parts, and this will always pass through the center of the circle. That's why it will become the diameter. Clear? Okay, let's solve some questions from the triad questions now. Here one of the question, it says given RS is equal to UT or congruent to UT. Now what are they talking about? They are talking about the arc. Arc RS is congruent to arc UT. Now where is RS? This one is congruent to this one, right? Now they are saying, how can you find UT? How can you find UT? Like where is UT? This is UT. I mean this one is UT. So how will you find how long is UT? First of all, I think all of you will understand from one of the theorem that we discussed that UT will be equal to what? It will be equal to RS. Both these chords, they will be of the same length because the corresponding arcs are congruent, right? Now how can we find? We look at this. I have this distance. How much is this distance? This one is 4. Let's say if I call this point M, this point M, okay, now how long will be this line? How long will be this line? Because this is the radius of the circle, so it will be 5.5. Now how can you find this TM or UM? Clearly you can see that this triangle TQM is a right angle triangle. Let me show you here separately. Here T, and then we have M, it's a right angle, and then here we have Q. Now Q to T, it's 5.5, and T to M, we don't know how much is this one, and how much is Q to M? It's 4, right? Now how do you find one of the missing side of the of a right angle triangle? So we make use of the Pythagorean theorem. What is the Pythagorean theorem? C squared equals A squared plus B squared. Now let's put the values into it. So what is the value of C squared? It is 5.5. Squared equals, what is A squared? Let's call this one, let's say A, and let's call this one B. So the two legs of the right angle. So we have A squared plus B squared means it will be 4 squared, right? Now how can we get the value of A squared? Move this 4 squared to the other side. So we have 5.5 squared minus, it will be 4 squared, right? So let's check what is it on the calculator. So it will be, let me show you the calculator here. So it is going to be 5.8. Okay, 5.5 squared minus 4 squared, right? So what is the answer? It is giving us 57 point, okay, let's change it to 14.25. So we have a squared equals 14.25. Now how can we get rid of this square? We can take the square root of this side, we can take the square root of this side. So let's take the square root of the answer that we got. So it is giving us 3.77, right? 3.77. So it's a equals 3.77. now this was this length tm is 3.77. how can you get tu? Because our question was how to find tu. So because tu, this point is the half, as we discussed in this theorem, that this point is in the midpoint, so this is the half. So it means if I want to get tu, I have to multiply it by 2. So 2 times 3.77 will give us I think 7.54. let me check. Now let me show you, like after this step, for example, you have this question in the multiple choice, and after this step obviously you have to understand how to make the values for each line segment and how to use this in the formula, which formula will be used. But I will tell you how can you get after this step directly this answer. Okay, so you will go to the calculator and you will write the same equation on the calculator. How will you write it? Look at this. We have bracket 5.5, close the bracket, square it, and then we have is equal to. Now this normal is equal to will not be entered. You will go to, look at this, there's another is equal to here that comes with this calculation key, and you can see that its color is pink. That means it will be done with this alpha. So alpha is equal to, what do we have on the other side? A squared. So rather than writing a squared, we will write x squared. So how can we write x squared? Alpha, and then you will press this key, it will give you x, and we have to square it. So square this one, and then we have plus, and then on the other side we have 4 squared. Directly you can write 4 squared. If you want to put it in a bracket, you can put it in a bracket, all your choice. Now if you will press this is equal to, look at this, it will always say there's an error. So actually we are not supposed to press this key. So how can you go back to your the values that you entered with this arrow key? It is giving you the same values that you entered in the calculator. How we will get the answer? Simply you will press this shift and then you will press this calculation. It will give you the final answer for the value of x. Look at this, it is becoming 3.77. It was here 3.77, and then you will times it by 2. Why do you have to times it by 2 to get the final answer? So times it by 2. It's again because look at this, it says it's an error, right? So you have to get the final answer 3.77 and then multiply it normally with 2 to get this answer, that is 7.54. right? So this part, the one that I have highlighted, can be solved directly with the calculator. Clear? So let's see what do we have next to solve. Here I have taken some questions from the exercise, from the lesson. All these questions are very simple. Only if you understood all the concepts that are given in the theorem, then these questions can directly be solved almost in all of them, no calculations needed. For example, here they are saying in the circle P, arc AB is 43. So where is the arc AB? We have the arc AB over here. So this one is 43, right? And AC, so this one AC is equal to DF, right? This one. Now what are they asking you in the questions? They are saying find each measure, how long is DF? Because AC and DF are equal. How long is AC? This part of AC is 2, and this will be the midpoint where my pen is moving. Let me show you with this. So this is the midpoint. So if this side is 2, the other side will also be 2. So this whole line AC is 4. So how long will be DF? It is also going to be 4. So we can say DF is equal to 4. How long is FH? Where is FH? So how long is the half of this one? Because H is the midpoint, so it's going to be 2. Similarly, solve the rest of the questions. Pause the video, solve the questions, and then play the video to check your answers. So here are all the answers. Quickly, if I explain you, question number 6, it was saying how long is the arc AB. So look at my pen, ABC. They want to know how long is this arc. So obviously A to B is 43. So this is this, you can say that this is in the half. So 43, and this side is also 43. So 43 times 2, it will be 86. How long is the arc DE? This arc, because the chords are equal, so the arcs will also be equal, so that's why it is 43. Similarly, AC will be the same as FD. We already found how long is FD, so it's going to be 4. Then they said how much is the arc DF, so this arc DF will have the same measurement as the arc ABC, so it's going to be 86. Right? Now look at these two angles. Before answering the question, I have to, look at these two circles. I have to check that are these circles congruent. To decide about any two circles that are they congruent, we have to check their radius. Now look at this. What is the radius of this circle? The radius of this circle is 5.1. What is the radius of this circle? This is also 5.1. Now the distance from the center, look at this, the distance from the center to the chord is 3.4. Here the distance from the center to the chord is 3.4. So it means the theorem that we learned can be applied to these two circles. Now what do they want us to find? They are saying TU, this line segment or this chord TU is 7.6, and they want us to find how long is PS. Now both these chords will be of the same measurement because they are equidistant from the center, 3.4, 3.4. So PR has the same length as TU. So if I want to get half of it, so I will divide 7.6 because TU is 7.6. So this whole PR will also be 7.6. To get its half, I will divide it by 2 and it will give me 3.8. Clear? Here is the next question for exercises 18 to 21 in circle B. Angle VBT and arc PR, they have the value 90 degrees. Now whenever they say angle VBT, so look at the diagram here, it's actually the central angle. So the central angle here is 90 degrees, and then they are talking about this arc PR, it is also 90 degrees. QR is equal to TU. Right now we don't need this for question number 18. Maybe we need this information for the next questions. So next they want us to find what is the value of measurement angle PBR. Better pause the video here, get the value, and then play the video to check your answer. Okay. Why this angle is 90 degrees PBR? Because the arc here PR is 90 degrees, and the central angle, it is giving us the value of the central angle. And what is the value of the central angle? It will be the same as the arc PQ, 90 degrees. So that's why this angle is 90 degrees. Clear? Here is the next question. Better pause the video here, solve it on your own, and then play the video to check your answers. How do I know that this angle QBR, because they are asking, the question is about the angle QBR. Look at this, QBR. This angle will be equal to angle TBU. How do we know? Because they said this QR, this, can you see here? Let me show you. Here we have a chord, a very small chord. So this chord is equal to this chord UT, because these two chords are equal. That's why the arcs will be equal, and that's why the angles that are made by these chords at the center will also be equal. So that's why we can say angle QBR is equal to the angle TBU. Clear? Here is the next question. It says how long is FG? Very simple question. Pause the video, get the value of FG, and then play the video to check your answer. So here is the answer. They wanted us to find FG. So FG, it has the same length as EG. So as I mentioned here, EG will be 21 here, 21 here. They have mentioned that this line segment is equal to this line segment. So if this one is 21, this part will also be 21. So if you add them, it is becoming 42. That's why FG will also be 42. Clear? Here is the next question. It says the diameter of a circle is 39 inches. The circle has two chords of length 8 inches. What is the distance from each chord to the center of the circle? Okay, so better first of all draw the diagram. So we have a circle in which we have two chords, let's say this one, and we have another chord, let's say over here, and they have the same measurement. Like they said these two chords have the same length. Okay, so let's name it. Okay, what is the diameter? The diameter is 39 inches, right? The diameter, they said, of the circle is 39 inches. So what will be the radius of the circle? So to get the radius of the circle, we always divide, or we get its half. So what will be the half of 39? It's 19.5. So let's write over here 19.5. What is the distance? Now each chord is 8 centimeters. So this one is 8 inches, sorry, and this one is also 8 inches. Let's name this one AB and this one CD. Now they want us to find that if you take the distance from the center to the midpoint of this line segment, and similarly the distance from the center to the midpoint of this chord, what is this distance? So they actually want us to find this, how long is this green line. So I'll not consider both the chords, I will just consider one of the chord. Now because the radius of the circle is 19.5, so can I join, let's say this is point, let's make it P. So if I join the point P with A, because P is the center of the circle, and I'm going to the point A, let's make it with a different color. So it will be, how long this line will be? It will be, as we wrote over here, it's going to be 19.5 inches, right? And this one, because it is cut at this point, is in the center of the circle, so this is going to be 4 here. So I'll erase this 8 from here, and let's name this point M. Now we have a right angle triangle PMA, and here you will have the right angle. So let's draw it separately. We have over here P, the center of the circle, here A, the point that is on the boundary of the circle, and this is point M, the midpoint of the chord, right? So this length is 4, this length is 9.5, and they want us to find the distance from the center to the chord. Actually they want us to find this distance. So because it's a right angle triangle, now better pause the video here and find how long is PM. So here is the answer. As you can see here, I did it on the calculator directly. Like if I solve this equation, what will be the value of x? So it is becoming 19.09, right? So we can say the value, I named this one x. So x is becoming 19.09, right? This is the 5 inches. So this is giving us the distance from the center to the chord, right? And if I solve it step by step, it is going to be 19.5 squared minus 4 squared equals x squared, right? So you can put all of this on the calculator, or directly you can write this side square root and all of this in the square root. It will be easy for you. So when you put all of this on the calculator, it will give you x equals 19.09. Like only this side of the, if you do not know how to use the calculator to directly get the value, you can do these 2 extra steps and just put this square root with these things on the calculator, and it will give you the answer, the distance of the chord from the center of the circle. I hope it's clear for you now. Here is the next question. Better pause the video here, solve this question on your own, and then play the video to check your answer. Here is the answer for this question, very long question. As you can see, they want us to find, this is the midpoint of AB, and they want us to find the distance from this P to the chord CD, and this will also give us the midpoint of the chord CD. So if I make this triangle separately over here, I have drawn it at this point, right? Now this P to D is the radius of the circle, and they have mentioned that the radius of the circle is R, so I wrote over here R. And then this distance I represented it with the letter X. Now how long will be MD? It is explained here. So check it step by step that this whole line CD is given 3 over 4 AB, and the measurement of AB will be R plus R, that will be 2R. And then because M is the midpoint, so you need to divide it by 2. So finally it will give you 3R over 4. Then to get this, it's a right angle triangle, I made use of the Pythagorean theorem. I substituted all the values. As you can check from here, step by step I solved it. I removed this square, it gave me 9R squared over 16. Then you can multiply each one of them here in the numerator by 16 and in the denominator by 16. So it will become like this, right? Then in the end take the square root, and finally this will be the answer. I hope I made it clear. Here is a challenge question for you. Better pause the video here and check which of the 4 options are correct. Maybe you have 2 correct, maybe you have all of them correct. So better check. Here are all the answers, that the first, second and the 4th options, these 3 options are correct in this one. Next we have some questions from the homework. It says question number 19, find how long is TV, where is TV, how long is this line TV. Okay, this one will be equal to what? It will be equal to PR. But no, they want us actually to find the arc TV. So where is the arc TV? This arc TV. It will be the same as arc, which arc? PR, right? Okay, so we can say that this arc TV is actually equal to the measurement arc PR, right? Why they are equal? Because as we know from here, angle VBT is 90 and also this arc is 90. That means this central angle is 90, this central angle is 90. So the arcs that are subtended by the central angles will also be equal, and each one of them will be 90 degrees, right? So if PR is 90 degrees, so this one will also be 90 degrees, right? Which segment is congruent to TV? So TV will be congruent to, I think it's very clear, it will be congruent to PR, because any arc PR is congruent to the arc TV. So here are the chords that are, you can say, corresponding to these arcs, so that's why these chords will be equal. Here is the next question. It says find a CD. Obviously CD will be equal to AB. What is the reason? So CD and AB are equal to each other. What is the reason? This is the most important thing that you have to know, because both these chords AB and CD are equidistant from the center. Both these are, you can say, 6 units away from the center. So that's why the two chords will be congruent. So CD is equal to AB, and we know that AB is 30 units, so that's why CD will also be 30 units. Now this is a very important question. It says, because no diagram is given, so whenever no diagram is given, so it's you can say you can make your question easy by making the diagram. They are talking about the chord in a circle that is 12 centimeters long. It is 30 centimeters from the center of the circle. So let's say if we draw the circle, we have a center and then we have a chord. Let's say the name of the chord is AB. It is 12 centimeters long. So this whole line from A to B is 12 centimeters. If you go from the center of the circle to the chord AB, you know that this is always the midpoint, right? And how much is the distance from the center? Let's say the center of the circle is P. So for P to point M is 30 centimeters, right? And this line AB was how long? It was 12 centimeters. So I will have 6 centimeters on this side and 6 centimeters on this side. Now they are saying what is the radius of the circle. So where is the radius of the circle? The radius of the circle is this one, and they want me to find it. This is a right angle triangle, so you can draw the right angle triangle separately, and this will be the hypotenuse of the circle. Better pause the video here and get the answer. So here is the answer. Like hypotenuse was missing. If you don't want to draw this triangle separately, you can draw it. It will be like this. So here we have the right angle. This is the point M. Here we have 6 centimeters. This is point A and this is point B, and we are trying to find the hypotenuse. So this Pythagorean formula will be used. Here is the next question. Better pause the video here, solve this question on your own, and then play the video to check your answer. Here is the solution for this question number 27. We have been given like the chord is 4 units from the center of the circle. So look at this. This is the center of the circle. I mean the distance showing from the center of the circle to the chord AB. And this is the midpoint M. These are 4 units. Here the radius is given 4 units. I have drawn the triangle separately over here. Then we want to find one of the leg of the right angle. I made use of the Pythagorean theorem. It gave me x equals 3. So this shows that this part of the chord is 3. I want to know how long is the chord AB. So you will do 3 plus 3 or 3 times 2. So it will become 6 units. So that's all for this video. Hope you understand it.